welcome back to my channel. So in this video I'm gonna go over tangent plane, and here we have a question over here which says to find an equation of the tangent line to the graph of the given equation at the indicated point. So this is the equation and this is the given point, and we are asked to find the tangent plane at this given point. Alright, so for this, first of all, you'll need to know the equation to find the tangent plane. Okay, so the equation to find it is f of x minus x0 plus f of y minus y0, and I'm gonna explain this equation in a moment, so don't worry if you don't get it right now, is equals to 0. Alright, so this is the equation that you will need. And yeah, you don't need to write the notes. I'm gonna provide the notes in the description below. Alright, so this is the equation, and you're probably wondering what is f of x, f of y, and f of z over here. So it's nothing but just the gradient vector evaluated at this point. Okay, so f of x means a partial derivative of f with respect to x, and here with respect to y and with respect to z. Okay, so that means our first job is to find the gradient vector. And if you guys don't know how to find the gradient vector, I've made a video on that as well, and the link to that video will be shown over here. So if you want, you can watch that out by clicking the I button or the link. Alright, so let's continue over here. So we're finding for the gradient vector. So f of x, f of y, f of z. So for the gradient vector, our first job is to calculate the f of x. I like to calculate it separately, not everything all together. I'm gonna write everything all together in here, but first let me calculate it separately. So f of x simply means the partial derivative of f with respect to x. These are the same notations, so don't confuse. Okay, we're differentiating with respect to x. That means all the other variables are treated as constant since it's a partial derivative. Okay, so y and z are constant, and this is our equation. We're only differentiating with respect to x. So that is going to be 2x. This is 0, 0, 0. Okay, now with respect to y, again, this is partial derivative with partial derivative of f with respect to y this time. Okay, this is going to be the same thing. We're only differentiating y, and x and z are treated as constant, so the rest is 0. Okay, next we have f of z. F of z, it's going to be the same thing, 2y, because we're differentiating only z, and x and y are constant in here. And 9 is already a constant. Okay, so now we have calculated the individual components. Now let's write them all together. So 2x I hat, 2y j hat, plus 2z k hat. You could have done it all together, but you know, when you have a really complicated problem like sine and cosine, when you have to do chain rule and stuff, then it gets complicated. So it's better to get used to writing it separately and then combining it all together. Alright, so let's continue with the problem. So we have the gradient vector over here, and our next step is to evaluate this gradient vector at this given point. Okay, so the given point to us is -2, 2, 1. Okay, so we are evaluating this point at -2, 2, 1. This is the x, this is y, and this is the, simply plugging in x, y, and z inside this equation. So 2x, see, it's -2. I had plus 2 times 2 j hat plus 2 times 1, because z is 1. Okay, 2 times 1 k hat. This is going to give us -4 I hat plus 4 j hat plus 2 k hat. And now we have our gradient vector evaluated at the point. And what is our next step? Okay, so now we have our f of x, f of y, f of z. The next step is simply to plugging in what we have calculated for inside this equation, and we will be done with this problem then. Okay, so this is our f of x, f of y, and f of z over here. And let me write it over here. so it's easier for you guys to follow along. Okay, so f of x is -4. So first of all, we're writing -4 and then x minus x0. So x minus x0. x0 is the point that is given to us already. Okay, so this is x0, y0, and z0. Okay, so what's x0? x0 is -2, and it says x minus x0. X minus x0, right? So that means x minus, and x0 is -2 already. So -2, so that means it's gonna become a +2, right? X +2. So that's what we're gonna write over here. X plus 2, and then plus f of y. What is f of y that we just calculated? It is 4. Okay, so then 4 y minus y0. What is y0? y0 is the point. That is 2. And it's positive, so we can just write it -2. Because it says -y0, right? And then plus f of z. What's f of z? F of z is 2. Okay, f of z is 2. And then z minus z0. What's z0? That's simply 1. So we write 1 over here. And then we need to make the whole equation equals to 0. Okay, making it equal to 0, and now simply have to simplify the equation to find the final answer. So then -4x, -8, +4y, -8, +2z, -2 equals to 0. Now putting the variables at one side and the numbers at the other side. Okay, so that's 16, 18. So that's gonna be -18 over here, right? At this side and equals to 0, but it's better to keep the variables at one side and the number at the other side. So I'm gonna move this 18 over there. So then this is going to be equals to 18, and this is the final answer. Thanks for watching. Bye, and don't forget to download the notes from the description below. Bye.